Okay, this is going to be the last one for tonight. So if you still have questions after this one, just please hold them until class tomorrow. We'll go over everything. Key thing about Lewis structures is that they are covalently bonded substances. I know that they're covalently bonded because when we have two nonmetals that bond together, that is considered a covalent bond. You also understand that this is when electrons are shared. And so what Lewis structures allow us to do is to show what pairs of electrons are being shared. And there's several different ways you can do these. Honestly, to begin with, I just tell students to connect the dots, which sounds kind of silly, but this actually goes back to electron dot notation, which is something you did a little bit ago. On this first one, we have NH3, and I see, or I know that nitrogen is in group 15, which means it has 5 valence electrons. And so I'm going to go through and go 1, 2, 3, 4, 5. You can write them clockwise or counterclockwise. It does not matter, guys, honestly, at this point. And then we see that we have 3 oxygens. We understand that nitrogen wants 8. It wants 8 electrons, and right now it has 5. I have 3 hydrogens. If you look right here, there are 3 electrons who are not paired up. We understand also that hydrogen is in group 1, which means that it has 1 valence electron. So here what we have is a sharing of these electrons, a sharing of these electrons, and a sharing of these electrons. So when I write out the Lewis structure, here's that lone pair of electrons that aren't bonded to anything, and then here are those 3 hydrogens. And that dashed line is just representing a covalent bond. Looking at the next one, H2S, you always put the most electronegative atom in the center, which in this case would be sulfur, unless carbon is present. If carbon is present in that compound, then you need to make sure that carbon is in the center. So we're going to go ahead and put sulfur in the middle. Another thing to remember about Lewis structures is that nature loves symmetry. If you really understand the organization of chemistry and biology, you understand that that's present. So we're going to have our sulfur in the middle. Sulfur is in group 16, and since it's in group 16, that means it has 6 valence electrons. Here we go. 1, 2, 3, 4, 5, 6. So right off the bat again, I know that it wants 8, and I've got 2 open spaces here. I've got these 2 electrons who really want to share with somebody. Oh look, I have 2 hydrogens. I'm going to put a hydrogen right here who has 1 valence electron. I'm going to put a hydrogen right here who has 1 valence electron. And now we see these 2 electrons are going to share. So I'm going to come over here and rewrite this out a little bit. There are those 2 lone pairs, those non-bonding electrons. And then here are those hydrogens. You do see that I'm writing those hydrogens at an angle, and there's a very good reason for that, and we will talk more about that tomorrow when we get to molecular geometry. CO2, carbon dioxide, is up next. Remember what I said a moment ago, if carbon is present, it's always going to go in the middle. Carbon is in group 14, which means it has 4 valence electrons. So here we go, 1, 2, 3, and 4. You see that nobody is bonded here, and everybody is wanting a little bit of love. Notice that you have 2 oxygens. Again, I said that nature likes symmetry, so we're going to go ahead and put 1 oxygen on this side, 1 oxygen on this side. Oxygen is in group 16, which means it has 6 valence electrons. So here we go. 1, 2, 3, 4, 5, 6. And you'll notice I have the dots different. You'll see why in just a second. 1, 2, 3, 4, 5, and 6. So here I see, this is where I say connect dots. These guys are going to share. These guys are going to share. These guys are going to share. And these guys are going to share. And you're maybe sitting there going, wow, carbon's doing a lot of sharing. Yes, yes it is. It's actually sharing 2 pairs of electrons. And so we are going to call that a double bond. And then there are those oxygens on each end, and we could go ahead and represent those lone unbonded pairs also on the carbon, or excuse me, on the oxygen. Last one. We've got hydrogen, carbon, and nitrogen. Carbon goes in the middle. Okay, anytime carbon's present, otherwise it would be the most electronegative atom, which in this situation you'd look at and say nitrogen. But again, carbon's there. And the reason carbon loves to share is because carbon has 4. Okay, it's got a lot of space. It's got a lot of places where it can easily do some sharing. So we're going to go ahead and put our 1, 2, 3, 4 all the way around. So taking care of the carbon, now I've got to figure out about the hydrogen. Well, you can pretty much put it anywhere. It's only got one valence electron. So we know that carbon's going to share with that one hydrogen right there. Then we have nitrogen. We're going to go ahead again, symmetry, and put nitrogen on the other side. It's not perfect symmetry, but it's the best we can do right now. Nitrogen's in group 15. So let's go ahead and put our valence electrons 1, 2, 3, 4, 5. You have 1, 2, 3 lone electrons who want to share. You have 1, 2, 3 lone electrons on nitrogen who want to share. So what would you expect to happen? We would expect some covalent bonds to come out. And this one definitely looks a little weird, so I'm going to redraw it. You see that 3 sets of bonds are being shared, and so yes, this would be called a triple bond. Okay. If you have more questions over those, these do take practice, but think of it like connecting the dots. Start by writing that most electronegative atom in the center or putting carbon there. Put your valence electrons around each and then connect the dots and see where you get. I'll see you all tomorrow.